Welcome, welcome. 2.1a, quadratic functions. So just to get started here, the definition of a polynomial function, math definitions, they always look kind of confusing, but let's see, let b be a non-negative integer, and we have all of this, all of the real numbers where a sub n does not equal 0. So a sub n would be like the term a1, a2, a3, a4. The function is given by this. So all that this means is a sub n, these are our coefficients, and then x has an exponent there. So the smallest that we can get down to is a sub 0, and that would just be like a constant. So basically this just means any like series of numbers where you have a coefficient and an exponent, and that makes a polynomial with a degree of n. So your highest power would be your degree of n. So for example, x to the fourth plus x to the third minus 3x squared plus 1. That's a polynomial. And this one has a degree of 4. But that's kind of just like a little bit of an overview. Today we're going to be jumping in directly into quadratic functions. These are a polynomial with the highest degree of 2. So the highest exponent that we have here is a 2. This is called a quadratic function. This is kind of a little bit of a review on what we were doing already last week on our transformations. And so what we are going to do here is it's just asking, how does this graph compare with the graph of x squared? How does this graph compare with this graph of like y equals x squared? So our typical parabola, which should be at 0, 0. Sorry about that. But how does this compare? So we see this negative sign here. That negative sign tells us that we're going to have a reflection. And so this would just be a reflection in the x-axis because of that negative sign there. And then this plus 1 tells us that we're going to do a vertical shift up 1. That's it, right? So this one, it would reflect down and it would go up 1. So it would be like this. This one, same type of thing. Downward shift 3. And then remember trickster. So this would go 2 left. So we go 2 left, down 3. And this one still opens upward because it's positive. So this is our general form of our quadratic, our standard form, a times x minus h squared plus k. Both of these are quadratic equations. This is our general standard form, which actually helps us to be able to find our vertex. So our vertex is the point h comma k. So there is that negative sign there, but this is really important to note that your vertex is h comma k, and there's that vertical line x equals h that shows the symmetry right down where it goes. If it has a greater than 0, it opens upward, happy parabola. If it has a less than 0, it opens downward. So if it's negative, sad parabola, happy parabola is positive. Okay, so this is where we're getting into something that like we want to make sure that we remember. Identifying the vertex of a quadratic function. This one is not in our form that we want it to be. We want it to be in this standard form, right? And it's not. So for this, we actually get to do completing the square. Woo, yay. Why am I not hearing cheers? I hope we're excited. Okay, so if we are doing this, what we have to do is we have to group our x's together and kind of leave a little bit of a space for this guy. We need to pull out the number out front, the coefficient of the x squared, because we can't have a coefficient out in front of our x squared. So we're going to pull out that 2 there. So what I did was I just factored out the 2 because they both have a 2. And I have this equation. So now what I want to do is I actually want to add in a number here. And we remember that we have that formula where you're taking this value here, you divide it by 2, and you square it to figure out what you're going to put in here. So 4 divided by 2 is 2. 2 squared is 4. So that's what we add. Now, if we like just randomly add something, we have to do the same thing to the other side, or we can like subtract it to the end because both of that would be the same. If I add it to the other side, I can subtract it back over. So you can kind of skip that step if you want to. But did I actually just add a 4 to this side? No. This 2 out front is actually making it an 8 because 2 times 4 is 8 if I had distributed there. So I'd have to add an 8 to the other side too because I can't just play magic and I can't play God here and just throw something in. Doesn't make sense. So I could subtract the 8 back to the other side. And now we're getting pretty close to my standard form. 7 minus 8 is negative 1, 2, and now I just need to factor this. Well, what multiplies to give 4 and adds to give 4? 2. So x plus 2 squared minus 1. So now I can identify my vertex really quickly. My vertex is h, comma, k. Remember, h is always that opposite because there should be a negative built into that equation. And now we have our vertex of our parabola. And we're happy. Okay, next one to remind ourselves, x-intercepts. So to be able to find the x-intercepts of a quadratic function, we actually have to complete the square again first because this one is not in our vertex. Or actually, we don't have to complete the square first. But if we wanted to find our vertex, we would need to do that. But for this one, we could just find the x-intercepts like as is. We do need to factor out this negative though, because we can't have a negative out front when we're looking for this if we're trying to factor it. So I pull out the negative, changes all my signs. And now I can actually factor here. Well, what's going to multiply to give 8 and add to give negative 6? Let's think about this. We could have negative 2 and negative 4. And so then we could solve x equals 2 and x equals 4. So these would be my x-intercepts. That's the fastest way if you can remember how to factor. Some of them do not let you factor, so you would have to do quadratic, negative b plus or minus b squared minus 4ac all over 2a. And if that's the case, we're taking our a, b, and c values. So we would go back to the original a, b, c. So it'd be negative b plus or minus square root of b squared. Oops, that's a positive 6, sorry. Minus 4ac all over 2a. So I get negative 6 plus or minus the square root of 36. Negative, negative, negative makes a negative. 8 times 4 is 32. All over 2 times negative 1 would be negative 2. So this goes negative 6 plus or minus the square root of 36 minus 32 is 4 divided by negative 2. We're working kind of messy here. Negative 6 plus or minus 2 over negative 2. So I can split this into two guys. Negative 6 plus 2 gives me negative 4 divided by negative 2, which gives me 2. And then negative 6 minus 2 gives me negative 8 divided by negative 2, which is 4. So I got the same things. So if you can't factor or if you just prefer, you can always do your quadratic formula there. Thanks, guys.